So draw the picture. If anything is constant, what do you suppose I mean by constant? Doesn't change. It's fixed. For example, one of the problems we're going to do in a minute is a ladder leaning against a house. Okay? Is the length of the ladder ever going to change? No, it's constant, so you don't have to assign it a variable, which means that we can actually put the constant on there. If it changes, it needs a variable. And so that's the kind of the key on there, okay, is when you draw your picture, if it changes, give it a variable. If it's fixed, label it with its value. It's going to save you time later on, okay? Once you create an equation from your picture that relates everything, you have to differentiate it and plug in what you know, okay? So let's try some because it's the only way to do these things. Number 3, I think. We'll start off with this one, okay? There is no formula to this. This is just kind of getting us started on how these work. Assume that y is 5x and dx dt is 2. Find dy dt. Okay, so here, x and y's are both functions of time. Okay, if you can imagine the line 5x. Okay, there's my line 5x. And as time goes on, okay, these x's and y's change depending on which way you're going, and we'll always assume time goes positive. Okay, so if I pick this point right here, okay, if there's some point moving, this point starts moving along this line, as time increases, the x is changing and the y is changing. They're telling me that x is changing at 2 units per unit of time, okay, and we could call that whatever. So it's going this way at 2, but how fast is it moving this way based off the fact that that line is 5x? So how do we do this? You have to differentiate this equation with respect to time. So what is the derivative of y with respect to time? dy dt equals, now what's the derivative of 5x with respect to time, with respect to t? 5 times dx dt. Okay, so the derivative of 5x is just 5. But x is some hidden function of time. We don't know what it is. We know its value is 2 at the moment that we're interested in. And so I have to multiply it by the derivative of the inside. This is chain rule going into effect for us. Okay, now they want me to find dy dt when dx is 2. dx dt is 2. What am I going to do? Multiply by 2. dy dt is 10 units per time. We have no idea what it is. Who cares? Okay, so this way it's only going 2. We could say 2 units per second. Okay, but how fast is the y moving? It's going 10 units per second as x goes this way. Why? Why is it going that much faster? Because of the slope of that line. Okay, so this point right here has essentially 2 components to it. There's the x component, and then there's this y one also. Okay, we know this one is 2. What we want to know is how fast is this one going? How fast is that y changing if this point was to slide across that line? And guess what? It's going 10 units per second, or however far that is. Okay, that's the general idea of how this works. So let's move to number 20. number 20, is when a circular plate of metal is heated in an oven, its radius increases at a rate of 0.01 centimeters per minute. At what rate is the plate's area increasing when the radius is 50 centimeters? Can we figure this out? Sure. Okay, putting this plate, and it's a circular plate inside of an oven. Okay, when metal heats up, it expands. Okay, and they told us exactly how fast it's expanding at a specific moment in time. When we know that, we can actually figure out at that same moment how fast area is changing, based off of the fact that, what do you know about the area of a circle? Area is pi r squared. Okay, so essentially what we have is we've got this metal plate with some radius. Okay, in the oven, it expands to this new radius and this new area. Okay, and we want to know, what is that? How fast is that area increasing at that same moment? Knowing that, so what did they actually give us in this problem? They tell us that the radius is what?
50 centimeters.
When radius is 50 centimeters, so we will have r is 50 centimeters. What else do we have?
Rate of change.
The rate of change. So they tell us that it's increasing at a rate of 0.01 centimeters per minute. What exactly does that represent? That's your dr dt is 0.01 centimeters per minute. Okay? And what do they want us to find? They want us to find not the area, but the rate at which the area. So find dA dt at these specific conditions. Okay? In order to find dA dt, I have to have an equation that's going to relate it to these two quantities. That's where that comes into play. Okay, so if A is pi r squared, and we already did this one, we can do it again. What is dA dt equal to? 2 pi r times dr dt. So the derivative of area, the rate at which the area changes with respect to time, is dA dt. Okay, and that's equal to, because if we're going to differentiate the left, we have to differentiate the right side as well. Taking the derivative of this also with respect to time produces 2 pi r times how fast that radius is changing with respect to time. Now, I want this value, dA dt, which means I must know r and I must know dr dt. Do I?
Yes.
You bet. They're right here. So what's dA dt equal to? 2 pi times 50 times 0.01 pi centimeters squared per minute. Why is it centimeters squared?
Area.
Because it's area, right? This is a centimeter unit, and this is a centimeter per minute, okay? R is centimeters, T is time, and this R is centimeters. R times R gives me centimeters squared per my unit of time. There's how fast the area is changing at that moment, okay? (23) is the ladder problem, and it has several parts to it. I remember right. So 23. A ladder 13 feet long is leaning against a house when its base starts to slide away. By the time the base is 12 feet from the house, the base is moving at a rate of 5 feet per second. Part A. How fast is the top of the ladder sliding down the wall at that moment? Okay? because we all want to know and can all quickly calculate before it hits the ground how fast it's really falling. Okay? So let's draw the picture. Here is my house. Well, that's good enough. With my 13-foot ladder. Okay? Now back to that question earlier when we draw our picture. Is this actually ever changing? No, we do not have to give it a variable. It's constant. We're going to put it on there. It's a fixed value, okay? Which means that its rate of change is essentially what? 0. Goes away. Okay, so if you've got a constant, when you differentiate it, it's going to go to 0. That's why we want to put those in there. Okay, now what do they tell us is happening here? They tell us that the base of this ladder starts to slide. Okay, if the base of the ladder slides, what does that actually force the top of the ladder to do? It's also going to slide down. Okay, so is this a fixed distance? Nope, because the ladder's sliding, this distance is changing. Is this fixed? Nope. So what do we have to call them? Variables. You have to give them names. I don't care what you use as long as you label them. Okay? And your picture is great for that. What do you want to use?
X and Y.
X and Y. Good. I was hoping you'd pick those. Given the fact that it's in a sort of an XY plane system, X and Y work very well. Okay? So we'll let this guy be X and this be Y. Okay? So if this distance is X at any moment in time, what does that make this rate of change right here? This is dx dt. And what does that make this rate of change? That makes this one dy dt. Okay? So we have two different rates of change. We have a dy dt and we have a dx dt. Okay? Now, what is it that they're asking us to find? Based off of our picture, dy dt. How fast is the ladder sliding down the side of the house? We have that labeled dy dt. So we have to find dy dt given what? What do they tell us? At what moment in time does it tell us that we need to find dy dt at? When x is 12. Given, or find dy dt when x is 12 feet. Anything else? And dx dt is what? 5 feet per second. Okay. So in order to find dy dt, we have to come up with an equation that has a dy dt in it. Dy dt comes from taking a derivative of y. So now when you come back to your picture, I have to somehow come up with a way to relate my variables. What can I use? Pythagorean theorem. We're going to assume that that is a right angle. Okay? And Pythagorean theorem says that the x squared plus the y squared has to equal the 13 squared, right?